Hello friends, this is Suresh and today we are going to learn about YOLO. Uh, YOLO algorithm and architecture. Now I explain about YOLO architecture. So briefly I will explain about YOLO Lite like tiny YOLO and YOLO V2 algorithm like Dark 19. Tiny YOLO consists that around 7 layer of CNN, and there are no patch normalizations, and that kind of regularizations don't have with tiny YOLO, and in YOLO we too have around 19 layer of CNN and five for like five max polling, and every layer uh, regularized by patch normalizations. So that all things improvement in YOLO V2. So uh, uh, that's why YOLO makes lot of significant number of error that called localization error, and that all things resolved in not completely, but yeah, somehow improvement in YOLO version 2, the improving recalls and localizations, and it maintains the classification error also, so that better performance achieved in the YOLO V2. Right now, YOLO V3, V like till V5 right now come in the markets. They have many layers, like more than 19 layers, like 32 layers and 75, and YOLO 5 have more optimization things. Yeah. But here I am discussing about YOLO V2, and that has advantage with YOLO version 1. So YOLO version don't have batch normalizations, but YOLO V2 have batch normalizations and better resolutions, and started with that predict the bounding boxes using anchor boxes concept. So that's and YOLO V1 not unable to get multi-class, like multiple object available in particular image. So in YOLO V1 that unable to get multi-class, only detect one object in one image. So right now that multi-object prediction can be done using in YOLO V2. That's like per grid cell. So per grid cell they can be like multiple object can be detected. So briefly I will explain about anchor boxes and how training going using anchor box in YOLO V2. So the concept behind that called grid cell. So first, whatever input uh, you will feed into network, then it will split into grid cell. So for example, for explanation, this image explanation of Andrew Ng, I'm taking reference from him, and and he's taking like 3 into 3 grid cell. So the number of grid here like 3 into 3, total 9 grid, and anchor box. So first I will explain what is the anchor box. So anchor box used for uh, with convolution that for predict multi object in per grid cell. So for example, here taking the k anchor boxes. So generally people use 5 anchor box, 6 anchor boxes. So number of the anchor boxes depend on your data. So like in size and aspect ratio of the anchor box, so also you have to select with your data. So that's called the anchor boxes, and anchor boxes have particular size, like this size, this, and this rectangle and square, whatever anchor boxes people are using. So now for explanation where we will use two anchor boxes, anchor box 1 this, and anchor box 2 size of this, and this two anchor boxes. So what will be the output with two anchor boxes? So first I will explain the output of the that convolutions output of this, like three first that call probability score, and four coordinates like x1, y1, and height and width. So top left coordinate is called x1, y1, and height of width this particular bounding box, predicted bounding box, and c1, c2, c3. So for example, we are taking three class: pedestrian, car, and motorcycle. So there are three class here. So total number of output is 8. So total number of output for complete this, that is called 16, because of there are two anchor boxes. So first anchor boxes output size is 8, second anchor box is output size is 8, total is 60. So that's why final output using 2 anchor boxes, that call this. And number of parameter in particular this, so the total is 8, and here 8, so per anchor box is 8. So that's why 3 into 3, 2 anchor boxes and 8 number of output. So so this is the output value of the y. So how training will go, now I will explain that. So we can start with first grid cell, this one grid cell, two grid cell, third, fourth, fifth, sixth, 7, 8, 9. So first grid cell, so there are no objects, so there are 0 probability score, and for second anchor boxes also with 0. So similar with happen for second grid, third grid, fourth grid, fifth grid, sixth grid, 7, 8 grid. So in 8 grid we are getting the car object here. So with first anchor box they are not getting any results, so second anchor box is the predicted car here. So that result for first 0 and second is 1 probability score, and that bounding boxes and result here. So similarly all the grid cell, so finally all the results they getting here. So this is how anchor boxes use and how training will going on. The algorithm will work in YOLO. So generally people generally per image in YOLO we too also using 19 into 19 grid cell per image. So that is actually use 19 into 19 grid cell, and that called 5 anchor boxes people are using generally as a, it's not benchmark, but like VSC and COCO dataset they use 5 anchor boxes. So 5 into 8, that called 88. 5 into 8, so like 40. So 19 into 19 into 5 anchor boxes into 8 output, that's called 40. So number of output, for example 19 into 19 grid cell, so total grid cell is equal to 1990, and output will be the 19 into 19 multiplied by k. K is the anchor boxes. So this number of box result we are getting. So but might be in particular bounding box, particular image only 2 class and 2 object is there. So but we are using this concept, we are getting like n number of outputs. So how we can suppress, how can remove all the outputs? So that's why here use NMS, that called Nonmax Suppression algorithm. So in Nonmax Suppression algorithm you use for reject all unnecessary predicted bounding box. So for example this is the image and there are 2 class, car 1 here and car 2 here, right? This is car 1 and this is car 2, and number of grid cell is 19 into 19. So 19 into 19 prediction we are getting here. So we have to reject all the prediction. So first of all, if you writing the algorithm, then step by step, like step 1, discard all boxes with probability score 0.6. So if probability score 0.6 below, then we remove all the boundary boxes where probability score less than 0.6. So that threshold a user can decide, like you want to delete 0.7 and 0.8 whatever. But yeah, then we have to loop over remaining boxes. So in loop over we have to 2 steps. First step, pick up the box with the largest probability score. So largest probability score 0.7 or 0.8, largest probability scores box we are pick up. So for example this is the largest probability score box we predicted and pick up. Then we discard any remaining box with the IOU 0.5. So like with the largest probability score bounding box. So other bounding score maybe like this. Here maybe like this. So we will check that the largest IOU, if we we get intersection or union, and if we are getting intersection union greater than 0.5, then we will reject, because we don't if already overlap that object, then we no need that bounding box, right? So so we have to reject that. So that's the concept here. So in this loop, for particular this car, all of the bounding box reject, and only one bounding box we are getting that have largest probability. In the second loop also same like we are getting the largest probability score for, we are getting for this largest probability score, and then we will remove if IOU greater than 0.5. So then again all the bounding box will be discard. So end of the loop, all the bounding box discards where there are no these results here, right? So that is the basic concept from max suppression algorithm, and using that we are getting the predicted bounding box and reject all other unnecessary bounding boxes. So this is my concept of NMS. Now I will go for the loss function. So generally people thinking about how YOLO work, in which loss function YOLO using, and what kind of the loss functions, and how manipulate the loss functions there. So here YOLO use three parts sum square error loss function here. So first is called localization loss term, and that penalize the bounding box coordinate. And second call that classification loss that penalize the classification confidence probability. And third is like confidence score. So here the final algorithm. So these are for bounding box. This first this loss for bounding box, like x1 y1 and height and width of. So if we getting error with predicting this bounding box like x1 y1 and height and width. So this is for predicted, and this is for this is for actual, this is for predicted, actual predicted, actual predicted, and actual predicted. So this loss. Second log like is object there and object is not there, right? If object is there, that probability, and object is not there. So second for object classification, right? And third finally that probability score. So this is called the probability score. So there are three laws, and some of the three laws that call YOLO laws. So this is final all about the how YOLO laws working on, and combination of the YOLO laws. Now brief about Darknet 19. So yeah, so I already talked about Darknet 19, around 19 convolution layer, 5 max polynomial layer, and every 19 convolution layer are regularized by batch normalizations, and it achieved 92% of accuracy, top of 5 accuracy of ImageNet, and is better than VGG, like 90% accuracy. And yeah, and YOLO network, that previously YOLO network. So this is all about the how YOLO works and loss function and architectures, all thing. So yeah, thank you, and thanks for joining this meetup.